Ambition, a relentless drive to achieve, improve, and push boundaries, is not just a personality trait, it has deep neurochemical roots. At the core of ambition lies dopamine, often called the motivation molecule. Have you ever felt an intense rush of excitement when pursuing a goal? That's dopamine in action, signaling reward anticipation and reinforcing effort toward long-term success. High levels of dopamine in certain brain regions, such as the prefrontal cortex and striatum, are associated with motivation, focus, and persistence. However, dopamine doesn't work alone. Norepinephrine, another key neurotransmitter, plays a crucial role in alertness and stress response, helping ambitious individuals stay sharp under pressure. Too much norepinephrine, though, can lead to anxiety or burnout, making balance essential. Interestingly, studies on high achievers, from elite athletes to entrepreneurs, suggest that ambition may stem from both genetic predisposition and life experiences. Some people naturally have a more active dopaminergic system, making them highly driven and reward-oriented, while others may develop ambition through habitual goal setting and reinforcement learning. Can we hack our brain chemistry to enhance ambition? Some research suggests that practices like setting small incremental goals, exercising, and even mindfulness can boost dopamine release, creating a positive feedback loop for achievement. On the flip side, low dopamine levels are linked to procrastination and lack of motivation, often seen in conditions like depression or ADHD. Neuroscientists are now exploring whether brain stimulation techniques or targeted medications could modulate dopamine and norepinephrine to enhance motivation and cognitive performance. Could we one day have a success pill that fine-tunes ambition? Ethical questions aside, understanding the neurochemistry of drive not only helps explain why some people are relentless in their pursuits while others struggle with motivation, but also provides insights into how ambition can be cultivated and optimized in education, business, and personal growth. What would you do if you could amplify your ambition at will? The future of neuroscience may hold the key. Ambition is strongly influenced by neurotransmitters such as dopamine and norepinephrine, which regulate motivation, focus, and goal-directed behavior. Dopamine, primarily released in the mesolimbic pathway, reinforces rewarding experiences and fuels the desire to pursue long-term objectives. Norepinephrine enhances alertness and energy levels, enabling individuals to sustain effort despite challenges. High dopamine activity in the prefrontal cortex is associated with greater persistence and willingness to take risks in entrepreneurial individuals. The role of neurotransmitters in ambition is like the fuel and ignition system of a car. Dopamine sparks motivation, while norepinephrine provides the energy to keep moving forward. Dopamine plays a crucial role in predicting rewards and reinforcing behaviors that lead to success. When individuals achieve small goals, dopamine surges, creating a feedback loop that encourages further effort. The basal ganglia, particularly the nucleus accumbens, processes these reward signals and strengthens motivation through positive reinforcement. Athletes training for a competition experience dopamine surges when they reach performance milestones, reinforcing their commitment to practice. This process is like leveling up in a video game. Each accomplishment triggers a rewarding response, motivating continued effort. Norepinephrine, released by the locus coeruleus, enhances focus and resilience by modulating stress responses. It heightens cognitive arousal and improves decision-making under pressure, which is essential for sustained ambition. An optimal balance of norepinephrine is crucial. Excessive levels can lead to anxiety, while low levels result in apathy and lack of motivation. Students preparing for rigorous exams benefit from norepinephrine drift alertness, allowing them to maintain concentration over extended study sessions. Norepinephrine acts like a mental espresso shot, boosting energy and sharpening attention when needed. While dopamine and norepinephrine drive immediate action, serotonin stabilizes mood and supports long-term perseverance. Serotonin regulates patience and emotional resilience, preventing burnout and frustration when faced with setbacks. Low serotonin levels can lead to impulsivity and short-term thinking, reducing an individual's ability to stay committed to long-term aspirations. Leaders and visionaries with balanced serotonin levels are more likely to sustain their ambitions through prolonged challenges without succumbing to emotional distress. Serotonin is like a steady heartbeat in an endurance race, keeping pace and preventing exhaustion along the journey. Oxytocin, often associated with bonding and trust, influences ambition in social context by reinforcing cooperative behaviors. High oxytocin levels increase social motivation and willingness to work toward group success, making it a key factor in leadership and collaborative achievements. This neurotransmitter helps ambitious individuals maintain strong professional networks and build influential relationships. And successful team leaders exhibit high oxytocin activity, enabling them to inspire and mobilize others toward a common goal. Oxytocin acts like social glue, binding individuals together in pursuit of shared ambitions. While moderate stress enhances ambition by increasing drive, chronic cortisol elevation can impair motivation and decision-making. Short-term cortisol spikes prepare the body for action, but prolonged exposure reduces dopamine sensitivity, leading to burnout and decreased persistence. Managing stress through mindfulness or structured planning helps sustain ambition without compromising mental health. Executives who balance high-pressure decision-making with relaxation techniques maintain long-term productivity without succumbing to chronic stress. Cortisol functions like a thermostat, keeping energy levels optimal when regulated, but leading to overheating if left unchecked. Endorphins act as natural painkillers, helping ambitious individuals push through discomfort and setbacks. Released during physical activity and moments of intense focus, they promote resilience by reducing stress perception and boosting mood. This effect is particularly beneficial in high-stakes environments where persistence is essential for long-term success. Marathon runners experience an endorphin-fueled runner's high, enabling them to overcome physical exhaustion and maintain endurance. Endorphins are like pain-dulling armor, allowing individuals to keep moving forward despite obstacles. Imbalances in neurotransmitter levels can lead to extremes in ambition, either hypercompetitiveness or lack of motivation. Excess dopamine may result in impulsivity or addiction to achievement, while deficiencies can cause procrastination and low drive. Personalized interventions, such as exercise, diet, and cognitive training, can help regulate these neurochemical pathways to optimize ambition. Overachievers driven by excessive dopamine may experience burnout, while individuals with low dopamine may struggle with chronic indecision. Maintaining the right neurotransmitter balance is like tuning an instrument, ensuring harmony between motivation, persistence, and emotional stability. Neuroscientific insights into ambition have led to the development of cognitive training techniques, neurofeedback, and pharmacological interventions that optimize neurotransmitter activity. Mindfulness practices increase serotonin and reduce stress, while structured goal setting enhances dopamine-driven motivation. Emerging research explores the role of brain stimulation techniques in amplifying ambition neural circuits. High performers use visualization and biofeedback to enhance motivation by aligning brain chemistry with goal-directed behaviors. Optimizing ambition is like fine-tuning an engine, ensuring all neurotransmitter systems work together for maximum efficiency.